Hi there, I'm Lian Duan. Welcome back to my channel. We already go through the Elasticsearch and Acker step concepts. Use a Docker or Docker Compose or Kubernetes to install Elk Living demo in previous videos. You may have questions. How are the log file discovered and collected by Filebeat? How does the Filebeat ensure that the log collection is sent to the target server without loss of piece of data? Your Filebeat hacks how to ensure that next collection starts from the latest states without recollection of logs. The memory or CPU usage of Filebeat is too much. How to analyze and solve it? How does Filebeat support Docker and Kubernetes? After you complete the video, you will have all the answers. The video topics are: what is Filebeat, Filebeat Component, and Filebeat Workflow. First topic: what is Filebeat? Filebeat is a lightweight data collection agent because it's developed by Go language. It doesn't need GR environment as logic stash. Filebeat can collect and ship log from source to logic stash or Elasticsearch. Filebeat is part of the bits family. Bits family include magic bits, hard bits, etc. All bits use a common library, Libbeat. The library can send the data from source to target server and make sure the log sent at least one time. I say the different bit has a different code to collect source data and then call Libbeat to send the data to the target server. Second topic: Filebeat Component. The diagram has three parts. In the left side is input source. In the middle part is Filebeat and the Libbeat components. In the right part, output target. Today we will focus on the middle part, Filebeat. Let's go Filebeat components first. Crawler component. Crawler is used to start input objects. Filebeat can configure multiple inputs. Crawler will start all the inputs. Next, input component. An input component is responsible for managing the heaviest and find all resources to read from. If the input type is log, the input finds all past matched files on the disk and start heaviest for each file. And then heaviest. A heaviest is responsible for reading the content of a single file. The heaviest reads the file line by line and sends the content to the queue. If a file is removed or renamed while it being heaviest, Filebeat continues to read the file. That has side effect. The space on your disk is resolved until the heaviest close. That may cause the Filebeat use too much memory or CPU usage. We can configure close inactive parameters to avoid that challenge. Next, module. Filebeat modules simplify the collection, parsing, and virtualization of common log formats, such as Nginx log, Apache log, Redis log, etc. Above has a link has more detail about Nginx log module. The module will be called heaviest collect data. Next, register. Filebeat keeps the states of each file and frequently fetch the states to the disk in the registry file. The states is used to remember the latest offset a heaviest was reading from and to ensure all log lines are set. If the output, such as Elasticsearch or logic stash, is not reachable, Filebeat keeps the tracking of latest line set and will continue reading the file as soon as the output becomes available again. When Filebeat is restarted, data of registry file used to rebuild the states. Registry file location is in /usr/share/filebeat/date folder. File name is log.json. The JSON file should be persistency. If not, after Filebeat restart, all log contents will be resent again. We quickly go over Filebeat components. Next, we move to the beats common library. Name is Libbeat. In Libbeat, there are two main parts we go through today: Publisher and Autodiscover. First, we go to Publish. In Publisher, client provides a publisher interface to let Filebeat send events to the memory queue. Event means log. Processor. Before being sent a log to the memory queue, the process will do the data process, convert, etc. There are two implementations of queue. Memory queue, it is based on the memory. Spool queue is based on the disk file. Memory queue is default queue. Filebeat normally does only take up 30 or 40 megabytes memory. In Kubernetes, we may run into memory use of Filebeat container around 200 megabits and sometimes triggers out of memory issue. The reason is in Kubernetes environment, especially the number of containers running on the bare metal, may cause large number of habits to collection logs, and then we face running into memory issue. We can add queue config to avoid the issue. I'll show the detail in the future video. Next, Acker. Filebeat guarantees events will be delivered to the configured output at least once and without data loss. Filebeat is able to achieve this behavior because it stores the delivered states of each event in the registry file. Acker is used to update the states to the registry file after output send an event to the target source. If Filebeat shutdowns while it is in the process of sending the events, it does not waiting for the output acknowledge all events before the shutdown. Any events are sent to the output but not acknowledged before the Filebeat shutdown. They are sent again when the Filebeat restart. This ensures that each event is sent at least once, but you will see the duplicate events being sent to the output. We can configure Filebeat to wait a specific amount of time before shutdown by setting the shutdown timeout parameter. Next, output. Output read the log from memory queue and send it to the target resource, such as Elasticsearch, Logic Stash, Kafka. Second part, Autodiscover module. When you run applications on containers, Autodiscover can help you to collect containers log based on the condition in Kubernetes or Docker. Autodiscover is in the filebeat.autodiscover section of the filebeat.yaml file. There is an Autodiscover config detail link. The link has all config items detail. I introduce the Filebeat and beats components. Next, I will show log file process workflow. To give you more detail, I turn on the Filebeat debug log level and take a screenshot for each step. The log content is from my previous install ELK stack living demo. Let us start the Filebeat workflow. First component is start crawler. Next step, crawler called input components. You will see input components read the log path from configuration file. Third step, register startup. Register will start to load log read states from log.json file. And then inputs use Harvest to collect the container log based on the states that from the registry file. This line shows Harvest read the container file, and based on the registry file, the current offset is 0. That means this is a new file. We didn't collect data before. File step, modules. Harvest check is there a modules configured. If yes, use modules to process data. If not, ignore. That line shows there is no module config because number of module configs find 0. That means there is no module config. 6 steps, client of publish start. 6 steps, client of publish start to send a log to the queue and use a callback function to process the log data. 7 steps, process kick in to process data. And then there is a memory queue information. The queue retrieves 50 logs. start from sequence 1 and sequence 50. And then output connect Elasticsearch to send data. There's a log show published event 50 events have been published to the Elasticsearch in 109 milliseconds. This number matches the queue capacity 50. The event number matches to the memory queue events. Final steps: Acker update registry status. Acker read the memory queue events and get the count is 50. Ready file is update. All topics are completed. Today we learned Filebeat definition and go through Filebeat and Libbeat components. I introduce the Filebeat workflow and showing each step in the log file. Thanks for watching the video. I hope it was helpful, and it was. Do not forget to like it. If you want to be notified whenever new videos come out, then subscribe to my channel. If you have any questions or something was not clear in the video, please post them in the comment section below. I'll try to answer. Thank you, and see you next video.